Hello everyone, welcome to this video. In today's video, we're going to be continuing our transformation lesson, but this time we're going to be focusing on things that are in function notation and things that are in vertex form. Starting with the vertex form, we have this equation with y is equal to ax minus h plus k. The a here pretty much does the same thing it did in the other graph. It's going to determine whether it opens up or down. It's also going to determine whether the graph is wide, narrow, or the same as the parent function. All of those different categories are considered vertical stretches. The h is going to be the x of the vertex. But you have to remember to change the sign. Just so that you know, in general, if you have a negative number inside of that parentheses, a negative number means right, and a positive number means left. The k in this case is not the y-intercept. The k here is going to be the y of the vertex. I'm only going to go through two of these because these are, after all the graphs that we've done in the past few days, this is nothing. The front number. The front number here is the number 2. So we have the number 2. 2 means we are twice as narrow, but it also means it's a vertical stretch by factor of 2. That vertical stretch answer is actually the better answer out of these, but since these are just notes, I'll leave both of them there. The parentheses in the x, right there it's a plus 4. If I see that it's a plus 4, that means that the vertex is actually to the left. So the number in the parentheses is a plus 4. This means the vertex is shifted left 4 units. The back number, what's being plugged in for k, we have the number 3. What's being plugged in for k is always going to be exactly what the y of the vertex is. So this number is 3, and this is simply the y of the vertex, which also means a shift up 3. Now let's graph this. A left shift of 4 and an upwards shift of 3. So I'm going to go left 4 and up 3 for my first point. Then, like we saw in yesterday's lesson, all quadratics are built off of the parent function. It would have looked exactly like the parent function if it wasn't for this shift left, shift up, and this one making it twice as narrow. To account for this twice as narrow, all that we have to do is multiply each y besides the one at the vertex by 2. Normally, we would have been right 1 up 1 and left 1 up 1 right there. Like on the normal parent function, the next spot is right there. Since this one is multiplied by 2, we're going to take the y value, and it's going to be twice as high as it would have been making this graph. If you don't like picturing it in your head like I was just explaining, then just pull out your graphing calculator, type this in, and then look at the table for it. You'll see that the vertex is at negative 4, 3. The next point after the vertex, one space to the right, is at 5. Number 2 should be just fine for you. number 3 should be just fine. 4 should be just fine. The only one that I'll go with next is the fraction one. This one that has a fraction, we have a negative 1/2. And the first column that we're filling out is the front number and its effect. So this negative 1/2 that's in front, this means we are flipped over the x-axis. It also means that our graph is going to be twice as wide, or it's going to be half as tall. So we can call this a vertical compression. By half. Or you could say by a factor of a half. The next two things we have to answer are the number in the parentheses and then the last number. The number in the parentheses here is a +4. A +4 means that we are going to shift to the left. Vertex shifted left. 4. The +3 means that the vertex was shifted up 3. Let's go ahead and graph these transformations. We're going to be left 4, up 3. There's our first point. And lastly, we're going to be flipped over, and our factor is going to be a half. So that would mean that all of the y's that would have shown up for the parent function are only going to be half as much. I'll use the graphing calculator for this one. Since the fraction is negative 1/2, I'm going to throw all of that into parentheses, so that way that happens all together. There's the graph. Here's the table. We got -4, -3 as the vertex, -5, 2.5, -3, 2.5, -2, 1, and the next good point is 0, -5. Go ahead and finish the other ones.